So let's talk about AC some more. AC power is man-made by the use of generators. So a generator creates AC power. A wire coil inside a generator rotates and produces current that flows from one pole of a magnet to the other, or alternates the direction of the flow. So as the motor's bouncing around those poles, it goes up, down, up, down, up, down, up, down, up, down, and off of each one we take a leg. So depending on what kind of power you're producing, 220, 120, 240, okay? 110 and 110 is 240. So that's how we build up the power, okay? So the more voltage we have when it's stepped up, right? We're gonna step up the voltage, and we know that when we raise voltage, we lower current. When we raise current, we lower voltage. It's a balance, right? So the other things that come into play is the resistance, right? Voltage equals current times resistance. So the number of revolutions made by the generator is called its frequency. In the US, we use 60 hertz. So it flows at 60 revolutions per second. So they run at 60 turns per second to produce a high voltage of 60 hertz cycles per second, AC, as they rotate. So as they go around, they excite these things, they go up and down, up and down, up and down every time they jump across. So AC power uses 3 wires. We talked about that. Neutral, hot. So you see how the 2 vertical lines are, one small, the small one is hot, and the big one is neutral, and the little one down at the bottom is ground. So the nominal voltage between 2 hot wires is between 220 and 240 volts. So the nominal voltage between a hot wire and a neutral wire is 110 and 120. So the ground is used as a safety wire, hot. So the ground is just what it says. It's a wire that goes out to the grounding of the house to keep everything in check. So when you have power come into your house, it's 240 volts or 220, and it's somewhere in there. It's going to be between 220 and 240. And then it's going to be between 110 and 120 at the wall outlets, because we're only using one leg off of the 220. If you divide that by 2, it's 110 or 120, depending on whether you have 220 or 240. So they chop it in half. And then it goes back through the neutral. So the neutral goes up, down, up, down. People think I can hold on to a neutral wire, but that wire is just as hot as the hot wire. It's just the wire starts, that's where it starts on the hot side. So everything's kind of polarized. Okay, so the neutral goes back to the panel, which all the neutrals are connected together, and you either have 220 volts on the hot wire or 110, depending on how many poles you're connected to at the generator, which is the source, the power plant. Okay, so direct current. AC is used for transporting low-cost power to users, but a computer's electronic equipment requires DC power. So we have to convert our AC power to DC power. That is what your power supply does. And a PC power supply's main function is to convert AC into DC. It does this by using a step-down transformer and using an AC to DC converter. So a step-down transformer steps down the voltage at your house. So on the pole out by your house, there's a big round bucket thing. Those are the things that explode, the transformers in bad weather and stuff. And they go, and they have green gel on them. You don't want to get that stuff on you either. So they step it down from whatever voltage is coming in. The big transmission lines are like 600 or 1,000 volts. They're huge powers. The ones that you hear going zzz, those are really high voltage, very low current, because they have high voltage. So at the little bucket by your house, they step it down from that down to 220. So it might be 600 volts, and they step it down, or 650, something like that. They step it down to 220. It comes into your house as 220. And then inside your house, we only take one leg of that and feed it off to our wall outlets. And that gives us the 110. Then the power supply in your computer steps it further down into DC voltage. So it actually converts it, okay? So it steps the voltage down and converts it from AC to DC. DC flows in one direction from one pole to another, and thus is said to have polarity.